So we're going to do a product to sum. Do a bunch of formulas and then do a few examples. We'll start reviewing for exam 2. Here's product to sum.
There's also, I guess I should say, also sum to product. So number 1, sine alpha times sine beta is equal to 1/2 times cosine alpha minus beta minus cosine alpha plus beta. Number 2, cosine alpha cosine beta is equal to 1/2 cosine alpha minus beta plus cosine alpha plus beta. Sine alpha cosine beta is equal to 1/2 sine alpha plus beta plus sine alpha minus beta cosine alpha sine beta is equal to 1/2 sine alpha plus beta minus sine alpha minus beta. Okay, now sum to product. Sine alpha plus sine beta is equal to 2 sine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. Sine alpha minus beta, that's going to be 2 sine alpha minus beta over 2 times cosine alpha plus beta over 2. cosine alpha minus cosine beta is equal to -2 sine of alpha plus beta over 2 times sine, let's see, alpha minus beta over 2. Last one for these guys. Cosine alpha plus cosine beta is equal to 2 cosine alpha plus beta over 2 times cosine alpha minus beta over 2. Double angle formulas. So I'm gonna give them all to you. Sine of 2 theta is equal to 2 sine theta cosine theta. What's up? Oh, yeah, yeah. No rush, man. Thanks. My hand?
Yeah.
It does sometimes. Cosine 2 theta has 3 different forms. Cosine squared theta minus sine squared theta. Number 3. Cosine 2 theta is also equal to 2 cosine squared theta minus 1. Fourth form would be 1 minus 2 sine squared theta. Okay. I think one more set. Let's see. 2 more. Put them on the next page. You guys cool on this page?
Leave me live one more second.
That's good.
All right, I'm good. Whenever.
Alright. So you can use either one of these three. Sometimes one's easier or more helpful than the other. Sometimes it doesn't matter. It's up to you, really. So. Power reducing. Sine squared x is equal to 1 minus cosine 2x over 2. Cosine squared x is equal to 1 plus cosine 2x over 2. Three, tangent squared x is equal to 1 minus cosine 2x over 1 plus cosine 2x. So these become very useful in calculus 2. I don't know how useful they'll be before then, but at least for this homework, you may need it. But that's the first time I thought that they were useful. All right, half angle formulas. Last set of formulas, promise. Sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Number 2, cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine over 2. Tangent of x over 2 is equal to 1 minus cosine over sine, which is equal to sine over 1 plus cosine. So weird equals, right? That's- Okay, so either one is fine. So in this, so I think we did equations, right? Last time we solved equations with sine and cosine and stuff. So we'll do some that require some of these formulas. So same type of deal. Yeah, this looks good. I believe this is problem 6 from your homework. Let me check. Yeah, let's do this one. Problem 6. Solve the equation. On 0 to 2 pi. So we can't factor sine or anything because we got that double angle in there. So look at the double angle formulas. What is sine 2x equal to? Yeah,
So 2 sine theta cosine.
2 sine. So whatever theta is, in this case, x. So theta is just generic. You know what I mean? So now we have it in terms of just regular sine. So now you notice you can factor, right? So from here to here, we replace this guy with this using this formula that we just wrote down. So factor sine, you get 2 cosine minus 1, right? So set each to 0 and solve. So sine x, sine x equals 0. 2 cosine minus 1 equals 0. Solve for cosine. That gets you to here. So what are the angles that satisfy both of these equations on 0 to 2 pi? So look at your circle. When is sine equal to 0? You don't have your circle. We can Google it, I guess. Oh, let's go. So the y is 0 at 0, right? Sine is 0 here. So that means that one of the answers or solutions, x, has to be 0. Okay. Now, where is cosine 1/2? Oh, also pi. Sine is 0 at pi as well, right? So this equation right here, sine, has these two solutions because it makes sine 0, or because that angle has a y value of 0. So now look for which angles will give me a half. Okay. So I get a half at pi over 3 for the x value, cosine value. And then I get another half at 5 pi over 3. Does that make sense? You see where these 4 answers come from?
Which formula did
It's the double angle formula, the first one. Any question on this? That clear? No big deal. Okay, let's do another one. Problem 9 on your homework. That's cool on this page.
Actually, I have a question about sine and then like 2 cosine of x minus 1 equals 0, and then why you broke it apart there, because I remember you mentioning like the difference in expression like that, but what, is there like a property or something you're using there to do that?
Setting each of these to 0.
Yes.
The property is called the zero factor property.
Okay.
So when you have something times something equal to 0, you can always set each piece to 0. Problem 9. So in here, all they want us to do is rewrite the problem. So you have a few questions where we want you to solve. On this one, they just say rewrite. Use the double angle formula to rewrite the expression. Okay. So 3 sine x cosine. So it looks like it's almost a double angle, right? In order to apply it, we would need 2 sine cosine, but we have a 3. If you look at the double angle for sine 2 theta, right? Looks like it's almost there. So you need to force it.
We just do 2 sine, cosine. Take 1 out.
I was thinking about that. We could take one out. We could also multiply them by 2/2, and then just separate the bottom 2 like this. I can always multiply by a form of 1 anytime I want. So then I can say, you know what? I'm gonna move that 2 down there on purpose and rig this question. See what I mean? So this 2 is right here. This bottom 2, I just put it down there. Since it's all multiplication, it doesn't matter. So this right here is going to be the double angle. That makes sense? I was thinking about this earlier. Like, what if I did 2 sine plus, oh, I don't have space. 2 sine cosine. Yeah, cosine,
Yeah,
cosine.
that's honestly was like the project I was doing, not project, problem in my own, that's what I wouldn't think of that.
I mean, I feel like it should both work, right? Let's try it for just for fun. What happens? This would be sine 2x plus sine x cosine x. So I still have this garbage. So I'd have to still introduce that 2/2, I think, in order to condense it. All right, so 2/2 cancels. It's as if it's not there, right? So you could do it this way and change the top. Oops. Which will then get you to here anyway. I don't see another way. Anyway, the point was to condense it into a single term using the double angle formula. However, whichever way you want to get there, doesn't matter.
I understand multiplying it times 2/2 is anything. What does it change anything? I don't understand what it's 3/2 is.
Oh, you mean the last step?
On the side.
Oh, this thing.
would be the path of least resistance, that is the side, that is worked it out.
So this side makes sense, right?
Yes,
Okay.
but 3 times 2/2 sine cosine, and it equals out to 3/2. Oh, okay, so you just put the denominator to 103 because it multiplies out. And then,
Yeah,
okay,
exactly.
I get it now. Okay.
Exactly. Let's picture a 1.
Yeah. Get it, let's say it out loud.
It's all good. I mean, it was a weird approach, so I don't blame you. Okay, that's my alternate here. So here is the answer. Take whatever path you want. Okay. Sample 3 says find sine of 2x, cosine 2x, and tangent 2x. Given that sine x is equal to -3/5. I think they have to give you this information here. Pretty sure they did. Let me check in just a moment. Yeah, I think it's this one here. Yeah, they did tell us. All right. So, what quadrant is this? Where is our angle? Let's see, fourth. So if we're in the fourth quadrant, sine is negative and cosine is gonna be what? Look at the circle. Yeah, it looks that way. We're in here, right? 3 pi over 2 to 2 pi. X is positive. Sine, cosine, the x. Sine is negative, the y. And if you were to do tangent, you do y over x, which would be negative divided by positive, which is negative. Yeah, so tangent is negative, sine is negative. Okay, that's what this tells us. They already gave us a sign, so that was obvious, I guess. Now, when you're solving for the x value, when you square root both sides, you're going to have plus or minus. You will choose the correct sign based on this quadrant. So a squared plus b squared equals c squared. So a squared plus negative 3 squared equals 5 squared. So a squared is equal to 25 minus 9. A squared is equal to 16. Square root both sides and you get plus or minus 4. So you need to know, do I choose negative or do I choose positive? I'm going to move this a little bit. So we choose positive because cosine is positive. Okay, so cosine is equal to 4 over 5. Tangent is equal to opposite over adjacent. I'm sorry. Yeah. So we got sine, cosine, tangent. Now we can answer the question, what is sine 2x, cosine 2x, etc. Right? So this one, when you need our formulas, sine 2x we said is equal to 2 sine cosine, which will be 2 times negative 3/5 times 4/5, which would be negative 12, negative 24 over 25. So there is a sine 2x. Any questions on what we did here? Does that make sense? We got sine, cosine from the triangle, and we just plugged them in, right? Okay, so now do cosine 2x. Choose whatever formula you want. So look at the double angle for cosine. Pick an easy one, I guess. Don't matter. I guess the cosine squared one looks a little better. I don't know. So that would be 4/5 squared minus -3/5 squared, which is 16/25 minus 9/25. What's 16 minus 9? 7. Yeah. So we're just using the formulas. Does that make sense? So do the same for tangent because I'm out of space. Okay. Any questions on 3?
Second to like,
Yeah. What was this? No, not that one. Oh yeah, you're right. I guess I forgot. That's weird. Could have swore I wrote it. Weird. Oh no, I just changed the square. Yeah, here. So it's gonna be 2 tangent theta over 1 minus tangent squared theta. You guys cool on this page? So we're good. Let's use the power reducing formula.
Oh, yeah, I got it. I just wanna make sure it's all right.
Oh, you weren't done yet?
Yeah, well, I just didn't know. I didn't know what the answer was.
Oh,
on it, so I was like,
my bad.
I want to make sure I got it right because,
This one, right? Number 3?
yeah, for tangent that is,
Oh, tangent. Yeah.
as long as it was confirmed though by. Yeah, right.
Appreciate you guys doing
Four
the.
fractions on top of each other, you know, like.
Yeah. Nice. I'm glad you tried tangent. That's cool. I didn't think you would. You guys get brownie points.
Just try it now or show up in the math lab. And ask lab and do the same thing, you know?
Yeah, sure. I used to be in that lab all day trying to figure this crap out. Use power reducing. Cosine to the 4th 2x. So it's basically cosine squared, right? So if we use that idea, we can apply the power reducing on the inside, right? Because the power reducing says that this will be 1 plus cosine 2x. Oops, actually, this was 2. I should put a 2 here. But this one becomes 4. Sorry. Let me write that better. Do you see the power reducing formula, how it doubles the angle? So it was already 2, so it's going to double it again. Although we still have a square here. So we're going to have to square the top and the bottom. So the bottom's easy, right? Just a 4. 2 squared. The top, though, life sucks. It has to be a FOIL. So that's going to be 1 plus 2 cosine 4x plus cosine squared 4x all over 4. I'm going to put this in front because I think it looks better. So do the power reducing again on this guy. So 1 plus 2 cosine plus 1 plus cosine of 8x all over 2. So we did right here, we did power reducing. Then again, here to here, power reducing. That space. Any questions on what we did here? How we applied power reducing twice? Do you see it? Is the algebra okay? Here? Okay, so this cosine squared right there.
Yeah, so that's when you turned it to cosine squared and you made it to 1 plus cosine 2x equals 2, but because it was 4, that's 8, right?
Yeah, so I doubled this angle here.
So the first part is just 1 plus 6 cosine, that makes sense. Okay.
Yeah, this is right here.
Right.
So this one, yeah, this is the same. So go ahead and multiply everything by a fourth, I guess. 2 times a fourth, that would be a half, right? Well, no, I'll leave it as a fourth. Oh, yeah, sorry. Okay. So all I did was multiply 1/4 on everything. That's it.
Well, that's your answer.
Technically, yes.
When we get knocked off, if we left it as 2 bars.
We should combine it all to one fraction. Technically, we can combine the fourth and 1/8, right?
So you just put it as 3/8, or
Yeah, let's do that. So let's change everything to powers of 8. That'll be 2/2, that'll be 4/8, right? 1/8 plus cosine 8. So combine everything, that'll be 2 plus 1 plus 4 cosine 4x plus cosine 8x all over 8. So finally that becomes 3 plus 4 cosine plus cosine 8x. Technically, this was the reduced form. It just wasn't simplified at all. But this is the pretty version. Do one more example and then we'll move on to review. Maybe 2. You guys cool on this page? Okay. Just let me know. There's no rush. Use half angle formulas. To determine the exact values. So part A is sine of pi over 8. To basically rewrite the question, into an angle divided by 2, just so you can apply the half angle. And you want to choose an angle that is on the circle. So this is the idea. We know that half of a quarter is an eighth, right? That makes sense? Or if we had it in degrees, it might be more obvious. Sine of 22.5 degrees is equal to sine of 45 degrees over 2, right? See how we're rewriting it? Same thing, this is the exact same thing. So in your formula, what is sine of the, you can call it theta over 2 or something? What's that equal to?
Plus or minus 1 minus cosine of 2.
So sine of pi over 4 over 2 is equal to plus or minus square root 1 minus cosine?
1 minus cosine.
So our x, sorry, should be pi over 4. Now, plus or minus, how do you need to choose one yourself. So the plus or minus will be determined by the location of pi over 8. So pi over 8 is in which quadrant? Yeah, it's pi over 4 is right here, so half of this somewhere over here, right? Somewhere right there. So we will choose plus. Positive because pi over 8 is positive in quadrant 1. So no more minus. Cosine of pi over 4 will be square root 2 over 2. Just plug it in and then start doing some algebra. And that's it. Combine these fractions, that's going to be what? 2 minus square root 2 over 2 divided by 2. This looks funky, which will be 2 minus square root 2 over 4, which would then reduce to 2 minus root 2 over 2. Any questions on adding these fractions? Do you see how this became this? Okay. All this is just algebra, so who cares? Do you understand the main concept?
I don't see how that, like at the end, where 1 minus square root 2 over 2 went to.
So this numerator
So you just, okay. Yeah, yeah,
becomes this. And then there's that 2 still there. This will make the bottom 4. Square root of 4 is 2. So that's why it became this. Any questions on the main idea? Does it make sense? You choose an angle that's on the circle, basically double it and then divide it by 2. It's like you're undoing it, kind of.
Just 'cause I'm curious, you mentioned that I'd like probably come across like trig stuff like this. How practical is this? And like, what are we learning here? You know, when you're showing, like, for example, like an angle, like square root of 2/2, like, these like, even if I memorize it's in between like 22.5 is pi/8 or whatever, you know, how practical is like this actual number that we're looking at the end, like square root of 2 minus square root of 2/2, like, would it even be looked at in those instances or broken down to this point in most practical applications of this kind of trigonometry? Do you understand what I'm asking?
Yes.
Okay, sorry. Because I just looked at all those squares over 2s and fractions.
I mean, it looks freaking weird.
Yeah,
It looks,
and
it
then I'm
looks
just like,
weird.
what am I even gonna, you know what I mean? Because like,
So basically, this is an exact answer. There is no rounding or approximation. It is what it is. As soon as I start using calculators, I can only approach this accuracy. So if I don't need this level of accuracy and I can just punch this in, right, to your calculator, then I can and get some nasty decimal. So like a bunch of decimal points will give me this. It'll repeat forever. But if I want an exact solution, right, because that's what they asked for, is that give me exact values. I had to do this to get there. But the exact answer is not pretty.
would the exact answer there differ from what you punch in initially?
If you punch in sine pi/8, you're gonna get some weird long decimal. You're not gonna get this.
Because it's an approximation of that, like, okay, well, but you're not gonna get like that fraction that we're looking at there, but if you punch in that fraction and sine pi/8, would that number be any different in its estimation? Like,
If no, yeah, they would be equal. They would both on the calculator punch give you the same decimal.
Regardless, okay. I see.
Yeah, this is just the exact representation. Like, for example, 1/2 versus 0.5 or 1/3 versus 0.3333 forever. So depending on what you're doing, sometimes you need more accuracy. The point of this is just to make you practice the formulas to understand how they work, understand what sign to choose, and then force you to practice your algebra. That's the point of the question.
Okay,
Does that help?
no, it actually, that answers a lot of my questions right now. Thank you very much.
Like, there's a lot of sections in this chapter where we're not solving for anything. We're just basically practicing the properties, like, so just to get it to sink in. That's almost the whole reason. Any other questions on number 5? Okay, we'll do one last one, then we'll move on to review stuff. Use product to sum, okay. Sine of 5 theta, sine of 3 theta is equal to 1/2 cosine. Go ahead. Al. No worries.
You're close to the faster.
Yeah, I will, as soon as I can. Minus cosine of 5 theta minus 3 theta. Okay. Oh, sorry. I'm a little out of it today. Okay.
Did you convert anything initially, or is that what it gives initially? Like, when with the problem being
Sorry.
presented to us, is it gonna get? It's gonna give us just sine 5 theta times sine 3 theta,
Yeah, I don't know why I started solving it.
and then we'll go straight into the.
Yeah.
So, but it won't give us the 1/2 and everything else. We're supposed to just.
Yeah, this is what you're supposed to do.
Okay.
I just started doing
From
it.
the properties.
So look at the formula. This is your alpha beta. So this is alpha minus beta. alpha minus beta. So it's just straight up from the formula. They're just testing to see if you can apply the formula. That's it. Nothing else. There's no actual like number or something. So you end up with this. This should be plus. Okay. But yeah, that's it. That's all for this section. I think we'll save the review for next time. We'll stop here. So Wednesday we'll do review, and next week we'll start hitting chapter 8 pretty hard. So try our best to catch up on the homework. That way you can just focus on reviewing this week. Okay, this weekend. All right, guys. You guys have any homework questions or anything you're struggling with? Doing all right for now?
You check one, and then I started another one. Can you tell me where I'm at? I think I've got it actually. I had this lady helping me. Well, started helping me in there, and then she started to get a little confused. But then said in my algebra privilege.
Sure. What number was it? What section?
It's 7.3, and it's number 5.
Number 5.
Yeah, that's.
That what you got?
I mean, mine is no, but well, mine's different, but yes, that's what I got effectively. I did it correctly.
Okay.
And I think I actually got it.
You got it?
I think
Am I
there's
checking it
only
out,
one
or-
other- there's one other one that I kind of started to get kind of stuck at, which was right here at this point on number 7. But, like that's where it was, and then when I got to this point, I started to like I don't know what you call it, I forgot, square it or do the opposite of it, and I don't know, it was 12. That was 12, and then I reduced the fraction here like to 3. Yeah, 4/3, and then I brought it down, and then I squared it there, but I wouldn't be like 2 over square root 3, and then I'd have to rationalize it 2 over square root 3 over 2, or over 3. And then where would that be on the unit circle?
Well, hold on.
It is like secant, so I would have to like put it over 1 and get a reciprocal thing too.
So you have 2 over root 3, right? Is secant. So flip it over. Oh, we get it. Cosine.
Yep. Okay, cool.
Because it's a reciprocal.
Okay, cool. Yeah, no, I got it now. Sweet. Damn. Flashcards worked for 2 other classes, but they were all like art and whatever. And
Yeah.
I didn't think it would work in here, but I feel like I kind of understand it a little better now after writing down the unit circle stuff.
mean, it
Every time
can't-
you bring it up.
It can hurt,
Yeah.
but I wouldn't say that's the only way to. That shouldn't be the only thing you do. It's about practice. If you don't practice, you're gonna fail.
Oh, yeah, well, I didn't know it until I did the flashcards. I didn't even understand the
Yeah,
concepts.
like just having them with you, I think is a good idea.
Yeah, well, I didn't, yeah, I can't even reiterate how many times when I had to ask them again, it's like the x-axis or whatever, like that was, my mom laughed at me at home and told me that I should change majors, like it
Yeah.
was like that, you know? So I was preparing myself for the worst, but I feel confident now.
I think you'll just put in the time, you'll be fine. And
Yeah.
yeah, if the cards work, go for it.
Oh, that's why I was like, when you said no one was here, I was here for like 2 hours in the lab before you, I don't know, I'm surprised you didn't see me.
I saw you towards the end,
Oh, yeah, I was here for.
right before the class started.